Okay, I want to help you try to do this problem, or at least show you how I would do it as your physics teacher. This is a core level problem. Accidentally drop an eraser out the window of an apartment 15 meters above the ground. Okay, so what am I going to do? I first identify that this is a kinematics types of problem because there's no real obvious discussion of forces. And I'm going to start out by drawing a picture. So I'm going to draw my person up there at the top of something that's 15 meters. So I'm going to write 15 meters right here. And a picture is always important. Here's my little eraser, and it's going to hit the ground down here. And next I want to think of a way that I can answer this question, how long it will take. I'm going to need some kind of relationship with time in it. And one of the ones that I remember, or I can look up, is that an object that is moving under a constant acceleration, in this case we'll call that little g, and that starts with an initial speed and an initial height, that this relationship holds. Now, that's something that you should try to prove to yourself every now and again, but let's see if we can figure out how to incorporate the various values that are in this problem. So hi in this case is the initial height, so I'm going to write hi equals 15 meters. I'm going to say that little g is the acceleration of gravity, so I'm going to pick an easy version of that, which is the minus 10 meters a second squared, and since it's dropped from rest, right, or at least it doesn't say, I'm going to say that that starts at 0 meters a second. So now I can use all of these values in the equation, and I can say that what I'm looking for is the time at which h of t is 0. So I want h of t to equal 0. So in order to do that, I now have h of t is 0, so I write 0 on the left, and I get a half g, so it's going to be minus 5 meters per second squared, times t squared, plus 0 times t, and then plus 15 meters, like this. Now I can move a value to the other side if you like, so I can write this now as t squared equals, and when I move that 5 meters a second over, it'll be a positive number, so I'm going to finally get over on the other side, I'm going to get 3, the meters are going to cancel, I'm going to get 3 seconds squared. So then if I want the time, I write it this way, the square root of 3, and then the square root of second squared will be seconds. And there will be my result for part A. Okay, now part B says at what speed will it reach the ground? Well, for that one, so this was part A up here. That was part A. And now in part B, how fast is it going when it reaches the ground? Well, an easy way, and another useful relationship here is that the speed of something that's going under an acceleration of constant acceleration A can be given by this. So I want to stick in the t that I have, and so v at the square root of 3 seconds. So stick in square root of 3 seconds into the input is going to equal 0, the initial speed, plus minus 10 meters per second squared times time. And now the time in this case is square root of 3. In fact, I should probably just have written that right away. So I can, in this case, write square root of 3 seconds. Okay? So finally, I get minus 10 root 3 meters per second. You see the seconds and one of those seconds cancels. So I get a meters per second. Okay, so that's part B. Now if we look at part C, it says if you multiply the time interval answer from A and the speed answer from B, why is the result much bigger than 15 meters? Well, let's just try that to see what happens. So if I take the, now this was our result here, right? If I take the speed that I got here, minus 10 root 3 meters a second, and I multiply it by root 3 seconds, I'm going to get square root of 3 times square root of 3 is 3, I'm going to get 30 meters. Now, that's not right because the fall was 15 meters. So what happened? Well, this speed times time, this speed times this time equals distance, is assuming that this is the average speed. And this is not the average speed. This is the speed at the end of root 3 seconds of fall. So the object is falling all the way down. As it goes faster and faster and faster. So it starts out barely moving, and it's faster, then it's even faster. So its average speed is not as much as this speed here. Its average speed is only half that much. So v average is actually 0, the initial, plus minus 10 meters per second divided by 2. That would be the average. So the average speed is really minus 5 root 3 meters a second during that time, although they didn't ask us for that in the problem. Okay, so that's that.